So now you know that our planet is 4.6 billions of years old. How do scientists can determine the age of a piece of crystal that occurs on the crust of our planet? So determining the age of a piece of Earth's crust is done to a process called radiometric age dating. It turns out that Earth's rocks contain small amounts of radioactive elements, such as uranium 235. Remember, these radioactive elements decay into other elements, and so they have a known period of life in the rock. This period of time that they exist in the rock is called the half life. For example, uranium 235 decays into lead 207, and it takes 700 millions of years for that to happen. So, if you have a rock sample with a known quantity of uranium, a known quantity of lead 207, you can determine the ratio of the daughter to parent isotope. In this case, your parent isotope is uranium 235 and your daughter isotope is lead 207. So if you know their quantities in the certain rock sample, you can determine the ratio from one to another. In this case, the ratio is of 63. If you know the half-life of the parent isotope, you can multiply the half-life by the ratio of parent to daughter isotope, so 63 times 700 millions of years, to get the age of your rock. In this case, 4.4 billions of years. So that would be the age of this rock. So scientists can determine the age of rocks found on the crust of our planet, on Earth's crust, the outermost layer of our planet, by knowing the half life and the ratio of parent and daughter isotopes on a rock. Radiometric dating can also be used in bones from fossils or even on pieces of uh, paper that are found on archaeological sites. So, this method of dating is implemented throughout several disciplines, throughout several scientific explorations.